Hydraulic features in urban drainage. In this video, we'll explore the key hydraulic devices used to control flow in urban drainage systems: orifice plates, penstocks, vortex regulators, and flap valves. Let's dive in. What are flow controls? Flow controls are devices used to limit the inflow to or outflow from elements in an urban drainage system. Typical uses include restricting the continuation flow at a combined sewer overflow to the intended setting, controlling water levels in tanks to ensure storage volume is fully exploited, and limiting the rate at which stormwater enters the sewer system. By deliberately backing up water in planned areas like car parks, we can prevent more damaging floods downstream in a city centre. Flow controls can be fixed, always imposing the same relationship between flow rate and water level, or adjustable, where the relationship can be changed by adjusting the device. Orifice plate. The simplest way of controlling inflow to a pipe is by an orifice plate. This forces the flow to pass through an area less than that of the pipe. An orifice plate is fixed to the wall of the chamber where the inlet to the pipe is formed. It either creates a smaller circular area covering the pipe or covers the upper part of the pipe area. The area of the opening can only be changed by physically detaching and replacing or repositioning the plate. There are two operating conditions. In a free outfall, the flow falls freely after passing through the orifice. The downstream pipe is not submerged. In a drowned condition, the downstream pipe is submerged, which affects the flow rate through the orifice. Penstock. A penstock is an adjustable gate that creates a reduction in area at the inlet to a pipe. The position of the penstock can be raised or lowered either manually or mechanically by means of a wheel or a motorized actuator turning a spindle. A penstock is more elaborate than an orifice plate. Its advantage is that it can be adjusted to suit conditions, either manually to an optimum position for operational requirements, or mechanically with remote control to respond to changing conditions as part of a real-time control system. Vortex regulator. A vortex regulator constricts flow, usually with the purpose of exploiting a storage volume. The magnitude of flow rate passing through the device depends on the upstream water depth. The regulator consists of a unit into which flow is guided tangentially, creating a rotation of liquid inside the chamber at sufficiently high flow rates. This creates a vortex with high peripheral velocities and large centrifugal forces near the outlet. These forces increase with upstream head until an air core occupies most of the outlet orifice, creating a back pressure opposing the flow. The main advantage is that it provides a degree of throttling only possible with an orifice of a much smaller opening, avoiding blockage or ragging problems that would occur on small diameter orifices. Flap valve. A flap valve is a hinged plate at a pipe outlet that restricts flow to one direction only. A typical application is at an outfall to receiving water with tidal variation in level. When the level of the receiving water is below the outlet, the outflow discharges by lifting the flap. When the outlet is flooded, the flap valve prevents tidal water entering the sewer. In these circumstances, any flow in the sewer will back up in the pipe. If the energy grade line rises above the tidal water level, there will be outflow. But the flap, which may have considerable weight, will create a local head loss. Summary of hydraulic features. Let's review the four key devices. The orifice plate is the simplest fixed restriction, a plate that reduces the pipe opening area. The penstock is an adjustable gate that can be raised or lowered, offering remote control capability. The vortex regulator uses spinning flow to throttle discharge without requiring a tiny opening that could block. And the flap valve is a one-way door that prevents backflow, commonly used at tidal outfalls. Each device has its place in a well-designed urban drainage system. Thanks for watching this video on hydraulic features in urban drainage systems. If you found it helpful, please like, subscribe, and leave a comment. See you in the next video.